Now the chapter on equilibrium is a chapter in theoretical mechanics. This question is from 9709, Cambridge A-level paper 4, mechanics 1, alright, for maths. It says a particle P is in equilibrium on the smooth horizontal table. So that's very important. Smooth means no friction is involved in this sum. It is under the action of 4 horizontal forces. These 4 forces are all horizontal. They are of magnitude 6 Newton, 5 Newton, F Newton, and another F Newton, acting in the directions shown. The sum wants us to find the value of alpha and F. So aim is to find alpha and F. Please bear in mind, alpha in the diagram already carries degree. So alpha is a number. F in the diagram already carry a unit of Newton. So F is also a number afterwards. So both the answers are numbers without units. We all know that for the equilibrium of a object or a rigid body, now the difference is if you are an object that has negligible volume, we are doing particle mechanics. That means we can assume the object to be a particle. And there is no question of moments in this question. That is why it is in Single Maths 9709, paper 4, which is normally taken as an A2 paper in maths. However, as we shall see later in the further maths questions, it deals with rigid body mechanics, meaning the volume, the area of the object is involved. Then we have got two things. Thing number one is what we call translational equilibrium. The term is not too important, but this is what we say by the resultant of all forces in any direction must be 0. And that condition alone is sufficient for particle mechanics. But if we are doing further maths, which I'll deal after this question, apart from translational equilibrium, you must have rotational equilibrium, right? Rotational equilibrium means the summation or the resultant moment about any point is 0, alright? So if in general we say equilibrium, as always asked in physics, we have to say for an object to be in equilibrium, the summation of forces or the resultant of forces must be 0. The resultant moment about any point must be 0. So since we are only concerned with number 1, for this sum, it is convenient. So before you solve a sum, please count the unknowns. The unknown in these questions are 2. One of them is F, the other one is alpha. Right? As we know, we can resolve in 2 directions, not necessarily perpendicular, but most of the time it's more convenient to make it perpendicular. So if I resolve in the horizontal direction, this force of 5 Newton, it will be good if you put this angle as alpha, because this angle is 90 degrees minus alpha. It will be easier. So 5 opposite it will be 5 sine alpha, going to my right, right? Plus 6 cos alpha, because adjacent, so 6 cos alpha is equal to the force going to the left, which is an F. So we have got one equation, two unknowns. We need another equation. The convenient equation to take is in the vertical direction. Right? Because the vertical direction, we know the angles, and resolving vertically, that's a symbol you may use. 6 sine alpha. Now, if it is cos alpha in the horizontal direction, in the vertical direction, it will become sine. That's the only component going up, is equal to the entire F downwards plus 5 cos alpha. So bear in mind, if you are having 5 sine alpha in the horizontal direction, the vertical direction will be 5 cos alpha. It can't be 5 sine alpha again. So we are essentially left with two equations and two unknowns, right? No doubt the equations involve trigo functions, but it is not a big deal. What I'm doing in this line is I'm substituting, I'm substituting F from equation 1 into equation 2, as you can see. Right? So rearranging sine alpha on one side, right? Cos alpha on the other side. As usual in trigo, in pure maths, sine alpha over cos alpha equals to 11. Alpha equals to 84.8. Note that I did not put the degree there. I also didn't put the degree there so that I won't lose a mark. Once we have known one of these, it's easy. Substituting 84.8 into either equations. In this case, I have substituted into the first one. I can get the value of F, again to 3 sig fig, right? So for all Cambridge A-level papers, if you are doing angle and it is not accurate, go to the nearest 0.1 degrees. If you are dealing with numbers, if they are not exact, go to 3 sig fig, right? So what I want to stress here is know your basics, and now you can see why physics and maths, especially mechanics, are so related, and also the pure maths. To solve two unknowns, you need two equations. And I'm afraid many students, even from my days, sometimes I myself also, before I became better, we simply wrote down a lot of equations which are neither independent nor necessary, right? So learn to count unknowns. Learn to count unknowns and attack the question. That means you have a plan. You have a plan before you attack this question. Now, let us see how much different or how much more difficult is the mechanics question in further mathematics, right? I must stress here that this is the dreaded part. Many students, especially, I don't know for what reasons, the girls, when it comes to further mathematics, they can score full marks for pure maths, they can score full marks for statistics, but when they come to statics, meaning equilibrium questions, many of these girls can only barely pass. I have helped some students, for many years, right? In fact, there was a very bright girl who only took 4 hours, of sitting down with me, and she understood everything, basically because she learned a more systematic way of solving this sum. So let us read this question. The diagram shows a central cross-section CDEF of a uniform solid cube of weight W and with edges 2A. That means it's a cube. So what we are doing is we are cutting the middle of the cube so that it contains the rod as well. The cube rests on the rough horizontal plane. Oh, that is very important. The plane is rough. That means this question involves friction. a thin uniform rod AB of weight W, it has got the weight, and length 6A, right? The word is uniform. Yeah? So what is uniform? Uniform, let's say rod, means its center of mass or center of gravity coincides with its geometrical center. Right? In fact, this is a very often asked question in physics, mechanics part of physics. So remember, when you say uniform, that means your center of mass or center of gravity is at the midpoint. Yeah, that's why it's called uniform. So then we go on to see the rod rests in smooth contact with the cube at C. Yeah? So remember, the contact at C is also smooth, meaning there is no friction at the point, only normal reaction or contact force. With angle CAD equal to 30 degrees. Now I must stress here, when you come to dynamics, whether it's dynamics or statics. Dynamics means things are moving, statics means question like this. They jointly form the mechanics part of further maths, like in anywhere else. The geometry is very important. Yeah, so if this is 30 degrees, it is chosen for some reason because of this triangle. Right? Everybody should know this triangle. Yeah? Okay, so not drawn to scale. If this is 30 degrees, sine 30 equals to half. And by simple Pythagoras theorem, we know that is root 3 and this is 60 degrees. Alright, so this is an important triangle because it comes out so often. So the rod is in the same vertical plane as CEDF. This one I said before. What the examiner is trying to tell you is a 3D problem is done by a 2D representation. The coefficient of friction between the plane and the cube is U. Alright, so there is a friction force there. Given that the system is in equilibrium, and I want to say something, it's in equilibrium. Equilibrium means it could be in limiting equilibrium or non-limiting equilibrium. Now, what's the meaning of limiting equilibrium? What's the meaning of non-limiting equilibrium? If you are in limiting equilibrium, F equals to mu r. When you are in non-limiting equilibrium, F is less than mu r. That means you have not reached your limiting friction. So if you just put equilibrium, that means F is less than or equal to mu r. And hence, before you even solve the question, look at the inequality you are having. That mu there has got a greater or equal sign. Right? The second part of the question, which is 4 marks, is to ask you to find the magnitude of the force acting on the rod at A. Now, my teachers used to tell me this. In the university, in the National Junior College of Singapore, and I learned most from them. If you can draw the free body diagram or the force diagram for a static problem, you are 50% from the actual answer. So note that at this point, I have a frictional force F because if anything happens, this is a hinge, the block will slide to the right. Since the block will slide to the right, the frictional force tends to act to the left, right? Opposing the tendency to move. This is the normal reaction R, right? I won't go into detail why it is not through the center and all that, because it has got 4 forces. Now let's look at the critical point C there. Please note that there is no frictional force because we were told that this point is smooth. Yeah, the contact is smooth. So it is 90 degrees to the, it has to be 90 degrees to the rod. And therefore, if you can mark this as 60 degrees, it is very important that you see this angle as 30 degrees. At the hinge X, right, at the hinge at A, X is the horizontal component and I label the vertical component Y. Now I want to share something which my seniors and our own group in the old days of A-levels in Singapore, we always say, after a lot of experience, solving a static problem like this often involves taking moments and two resolutions, not necessarily vertical and horizontal. Sometimes it will be more convenient if we take them still at parallel angles, but not necessarily vertical, horizontal. But most of the time, it is horizontal and vertical, like what I did in this sum. So we only have rotational equilibrium, from which we take moments, and we have translational equilibrium, meaning the resultant of forces in two perpendicular directions especially are equal to 0 for us to write out three equations. Now, this whole sum of part 1 is talking about mu. So in our mind, okay, long before we solve the sum, we should know where we are aiming. We are aiming for F less than or equal to mu r. So we concentrate on finding, F and R. But in the process, sometimes, it is more judicious, if you are clever, after a lot of sums you have the experience. If I take moments about X for the entire system, please remember force N becomes an internal pair of forces. So they don't appear. What appears will be, right, the force W, the weight of the block, the force W, the weight of the rod, which acts at the center. So, as usual, I give preference to taking moments because I want to get rid of X and Y. I don't want to bring them in. So take moments about points that you got the most number of unknowns, right? And before I take moments, I already know N will not come in. Therefore, an F is passing through A, and it has got no contribution to the moment. I will get the answer for N. Alright? I will get the answer for N if I take moment about X. Okay? So, for the rod only, I must say this here, for the rod only, that means leave the block alone. Clockwise moment equal to anti-clockwise moment. Anti-clockwise moment is N times 4A. Clockwise moment is W into 3A cos 30. Doing all the trigo there, you end up with N equals to 3W root 3 over 8. Hold it there. You must learn to analyze. The minute I know my N, I think F and R are known there. Because for now, I'm going to consider the cube only. When I consider the cube only, I can now resolve horizontally. Since I know N, F will come out, okay? So the horizontal component of N will be N sine 30, as you can see. So N sine 30 going to the right equal to F going to the left. So doing the necessary trigo, F is 3 root 3W over 16. Alright? So I might have skipped that step there, but I can show you here. 3W root 3 over 8 sine 30 is half, so quite easily I got that. And when I resolve vertically, true to what I said at the beginning, one moment, two resolution. Again, it does the trick. I need R. Don't remember? I need R. So I resolve vertically. R, which is the normal reaction force on the cube, is nothing but n cos 30. Why n cos 30? Because just now in the horizontal direction, it was sine 30. It must be cos 30 now. Plus the vertical force, which is F. And with that, I get my force R. And after simplifying, it ends up to be 25 W over 16. Now you can pause the video to calculate that out yourself, but I leave it to you. And then I reach my plan. F is less than or equal to mu R for that surface DE, from which we do a simple multiplication and simplification. We can show successfully that mu, the coefficient of friction, is greater than or equal to 3 root 3 over 2W. Shown. For part 2, normally if you can solve part 1, part 2 shouldn't be a difficulty. It says find the magnitude of the force acting on the rod at A. Meaning, I want my X, I want my Y. Now, you must be smart enough. Don't involve N. Take equilibrium for the whole system. Alright? So, we have taken moments, and now we are just want X and Y. There are two unknowns, and we have got two equations, right? Because Y plus R is in the vertical direction. So resolve vertically, you're running short of time, you can just write that. Equal to W plus W. So Y becomes 7W over 16. Right? And we know X. Sorry, I didn't even write there. I should write in the exam. X equals to F for the whole system. So therefore, this value of X is actually the value of F just now. So, using Pythagoras theorem, the force at A has got magnitude square root of X squared plus Y squared, and doing the necessary surd, you end up with the correct answer, which I should rightly underline. Alright, so please leave your answer in surds. Leave your answer in surds, okay, because this is a 4-mark question. Try not to punch calculator. Now I'll do one more sum from another year, slightly different configuration, but same emphasis. Now let's look at this sum. It looks scary. It looks scary, honestly, before you are good. Because there is one rod AB, there's one rod AC. Right? And two uniform rods AB and AC, again uniform. The examiner is kind enough indicate the forces there for you. And they have lengths, uniform rods, so midpoint. They have lengths 2A and 4A. Make sure all those are there with weights W and 2W respectively. They are freely hinged. And this I want to highlight. Freely hinged means a free hinge. Anything that's freely hinged, or smoothly hinged means the same thing. It means able to provide a force or a reaction, unable to provide a moment. So it is like, a loose nut, joining two rods. Alright? So if I have a pair of compass, this joint here is not a free hinge because it's able to resist moments. However, if I were to loosen this 100%, then this thing will not stay like this. That means it becomes a free hinge. So most of the questions that you will get, in fact all, the hinges are free or smoothly hinged, meaning they are able to provide a reaction force, but they are not able to provide any counter moments. Right. So the plane containing the rod is perpendicular to the wall, obviously. That makes it 2D. The rods A and B each make an angle beta. Make sure it's in the diagram. Show that the magnitude of the frictional force acting at AB, on rod AB at B, is 5/4W. Yeah? So, let's not forget the two parallel vertical walls are both round. That means this question involves friction here, involves friction there. The first part of the job, show that the magnitude of the frictional force acting on AB and B is 5W/4. For that, you get 7 big marks. Question number 2, given that the coefficient of friction at B and C are equal to mu each, find the set of possible values of mu in terms of beta. 7 points. So, once again, I cannot overemphasize the importance of a well-labeled diagram. So I have copied this diagram and I have inserted extra forces, normal reaction at C, frictional force at C, normal reaction at B, frictional force at B. Now, it is important that you know how to put the direction of friction. Now, if anything, these two rods will slide down. So the frictional force tend to oppose them. That must be correctly done. Right? So again and again, give preference to taking moments. Right? Resolve only when necessary. So, for rod A, I take moments about the point A for rod AB only. That's important. Alright? Meaning, I am taking moment about this point. So at the point A, there actually are internal forces. Y there, X there, which I'm not drawing. So on the end A for rod AC, the Y and X are just opposite. So when you combine them as a system, these internal forces cancel out. But when you take moments about A, that's why again, I take moments about the point I have maximum number of unknowns. By doing this, I can get, right, WA sine beta plus RA 2A cos beta. These are what you call anti-clockwise moment about A, and the clockwise moment is FB 2A sine beta. What I want to stress here is FB and W, because they are parallel, they will be dealing with the same trigo ratio. And for RB, because it's horizontal, therefore the trigo ratio is cos beta. So dividing throughout by A, and cut all the A's away, and dividing throughout by cos beta, you don't have to worry. People who mark your A-level further math script, are as good or better than me. We know what you're doing. Alright? So again, let us count our unknowns. We've got RB, we've got beta, and we got FB. Right? So, I have got 3 equations there, although the one deal with 2. Now I take moment as C for the entire system. Now that is very smart, because I'm not introducing extra forces. I'm trying not to bring X and Y in, and my unknowns remain. Okay, again, a bit of pure maths there. You may not know, but I hope this opens your eye. Alright? FB remain my unknown. Yeah? FB, and beta, right? They remain my unknown. Okay? or rather FB and RB, I'm sorry. FB and RB remain by unknowns. So I repeat the process at C, right? 2A, 2W first, the near one, times 2A sine beta. As I told you already, if W is sine, this 2W will also be sine. Alright? Plus, this W from far away, now here you need a little bit of geometry or trigo. You take the lever arm as a sum of this and this. Alright? So 4A sine beta is this line. A sine beta is that length. So W is 4A sine beta plus A sine beta. Now friends, all things considered, all things said, you must have enough practice in order for you to have the sensitivity and sharpness to write things like that. Otherwise, finding this lever arm alone can cause a lot of trouble. So equal to FB. FB is vertical, so again I say it has something to do with sine beta, and if you are smart enough, this is 6A sine beta. Alright, 6A sine beta is this whole length. Okay, this one was 5A sine beta. Plus another clockwise movement, RB. Now this one you got to be very careful, even worse than just now, because RB, what you want is this perpendicular distance, or this lever arm. Now you cannot get it straight away. You must get this lever arm minus that one. And that's what makes mechanics a little bit tricky, because apart from forces, you have to be reasonably sharp about all this basic geometry. That's why I have got 4A cos beta minus 2A cos beta. So I think that's a bit long. Never mind. Simplifying this, pause the video, work it out yourself, please. You get another equation. In fact, solving these two equations, right? Solving these two equations, two unknowns, RB and FB. Sorry about the blue ink, but you can see. I actually solved FB. I actually solved FB and showed. And until there, I had 7 marks. I have to tell you, this sort of question is not difficult, but the geometry, the configuration of various sums, you must try. The next video, we probably will do one where it involves a cylinder. Right. So, we have done everything. Now that I have got FB, alright, I should actually, on second thought, I should have substituted that straight away and it becomes shorter, but never mind. Let's say you didn't see anything, right? I still write back the same line, just that I substituted 5W over 4 for FB. I can get RB. Okay? So pause your video to work through this. Now, I want C. If I want C again, that's why in the main question, I don't want to dirty the diagram, because I never intended for Y and X to come in. If I resolve vertically, I get FC plus FB, they should be equal to the total of the two weights. Therefore, I get FC equal to 7W over 4. Then it is bingo, because I have gotten what I wanted. I can get mu by F at the point B, since it does not say whether it's limiting or unlimiting equilibrium, so we put the general case and we can get mu equal to that. And FC, I get mu equal to that. You must be careful. Take the stricter of the two things. So if I'm more than 7 over 3 tangent beta, of course I can satisfy the point B. So what is critical is at point C. Alright? So that is the whole question. Don't worry, I've checked the mark scheme. The answer is correct. And I urge you, wherever you are, spend some time going through these 2 sums, 3 sums, and do more on your own. Bear in mind what I said, okay? Take moments as far as possible. Right? Take moments as much as possible about points where there are maximum number of unknowns. Normally after that, if you can still take movement, take another one. Otherwise, it is likely to be 2 resolution. Right? In 9709, this is missing because you are dealing with particle mechanics. Alright? In 9231, you do everything. Huh? So 9709 is maths, paper 4. Alright? Which is mechanics 1. In 9231 is further maths, paper 2, which includes 4 or 5 mechanics question. You may have to take some time to do all this because let me tell you very frankly, back in 1972, I spent 6 weeks studying 16 hours every day with no resources except past year papers, no solutions except the final answer. When the term was over, when the year-end holiday was over, I became as good as my teacher. So can you. Yeah? Good luck and see you.